It's Mr. Gagnon here. We're looking at the last concept in energy, and that's the term power. So I'm gonna just put that up top here. Power. Okay. Now, I always like to tell this story, and it's better to tell it in person, but I'm gonna tell it to you anyway. Now, when I was about 10 years old, we didn't have video games and all that other stuff that you guys have to keep busy. So I lived in the woods. We had we didn't have too much going on. I had a couple of friends I used to play with a little bit. Um, you know, maybe two or three neighborhood friends. So one day, it was a nice summer day. I decided uh, to dig a hole. Again, this is what we did back in the old days. I took a shovel out of my dad's shed, and I wanted to dig a hole as deep as I could. In fact, I wanted to get to the other side of the earth, the earth, and I wanted to see what was on the other side of the earth. But I learned quickly that digging a hole was definitely a tough job. So and when I dug the hole, when my dad got home from work, he noticed that I had dug about a 6 foot deep hole, and I started actually started to tunnel underneath. So when I got down as deep as I could, and then I started to tunnel underneath, like in the bottom of the hole. I started moving it toward and I wanted to go under the street. Now, obviously, it was not a safe situation, so Dad quickly filled the hole in, and I got in trouble for about a week. Here's the relationship to the story. Now, okay, so here I am. Okay, I'm a little kid, right? Little kid standing here. I managed to dig this hole, right? Nice big hole. And let's say it took me 8 hours to dig the hole. So here I am, 8 hours later, I got a hole there that I can play in and whatnot. Now, okay, so let's say I'm a little older, and I say, well, I got to dig a hole just like I did when I was a kid. Except, okay, here's the hole. Okay, except instead of me digging it, okay, I end up using. I know you can't see that too well, but yeah, I end up using a tractor to dig it. And instead of 8 hours, it takes me 20 minutes. Now here's the question for you. Which one did now this whole pretend it's the same size as this, exactly the same size. Which one of these things, the tractor or the 10-year-old Mr. Gagnon, did more work? Take a second to think about it. Which one did more work? Well, now that you've had time to think about it, if you chose me, you're wrong. If you chose the tractor, you were wrong. We did the same work. The same thing was accomplished. The same amount of dirt was taken out of each hole. The difference is that the tractor did it much quicker. Okay? So, the difference is that the work was the same, but the power is different. So, if we look at the term power, I'm trying to get this focused in for you guys. Power has something to do with the amount of work that's done. All right, so let's take a look at it. Power, we'll call it P, equals the amount of work done per unit time. So I'll actually write it in for you. It's going to be W over T. So how powerful something is how much work it gets done in the amount of time that you have. So look, work is an energy unit. It's joules per second. In fact, a joule per second is something called a watt. Okay, and we'll call that W. And yeah, it's actually the same watts that you're thinking about when you think about electronics and light bulbs and such. So let's say we were to do a problem like this. Our answer is going to be in watts. And that's how much work is done per unit time. So it's the same watts that you're thinking about. Yep. So if I got a 100-watt light bulb, that's 100 watts of power for the light bulb. Now, if I want to go a little further with this, okay, I can do what's called a watt to horsepower conversion. Horsepower is a measure of power. So if you're into cars and things like that, like I was and I still am, I would rather have a unit in horsepower, because I know what horsepower is more so than I do watts when it comes to cars. So there was a really cool lab that I had for you guys. It was actually to calculate the horsepower of your legs. I'm going to put it on there as an optional assignment for you, and I'll actually count it as extra credit. I know some of you guys might want a little extra credit or need extra credit. I'm going to put it down on the bottom of the schedule and give you some extra credit for calculating the horsepower of your legs. And I'll explain in the video how to do it. And all you'll have to do is just send me Google form fill out. You'll have to fill out a Google form and let me know how you calculated horsepower. So, but for now, let's keep power units in watts. Horsepower is it's more designed to measure high power items like cars and things like that. But for ourselves, okay, we're not going to get too much higher than watts. So I'll give you an example really quickly. Okay, let's say that I needed to find the power of something that does 200 joules of work in 10 seconds. Well, let's see. Get rid of a 0. Okay. Something that performs 200 joules of work in 10 seconds would have a power rating of 20 watts. Okay, so that's as simple as it gets, folks. That's how to calculate power. So I'm going to leave it there. Okay, yes, you're going to have to maybe, given different variables, I might give you work, I might give you power, I might ask you how long it takes to do something. All right, and the horsepower activity will be something you guys do at home. You can only do it if you have like stairs. So if you don't have stairs, let me know and I'll try to give you an alternate assignment. But that's that. Okay, hopefully everyone's doing okay, and please let me know if there's any questions.